Hello guys, in this video we are going to talk about network performance. So what network performance is? Basically it is how good the performance of the network is. Network performance is measured in following fundamental ways: bandwidth, throughput, latency. So these are the three things that will decide your network performance. Okay? Now basically you do understand what network performance is. It simply is how good your network is, how much effective and productive it is. All right, so that will be decided with the help of these three things, that is bandwidth, throughput and latency. First of all, looking at bandwidth here, what bandwidth is? So basically bandwidth will be the maximum amount of data. So what the maximum amount of data is that you can transmit through that channel. Hence that maximum amount that will be transmitted through that channel in a certain period of time, suppose in 1 second. So how much maximum amount of data you can transfer in a single second via that channel, that is going to be the bandwidth of that channel. This was informal definition. Coming on to the formal definition, it's not more and it's not more different. It's simply the bandwidth of a network is given by the number of bits that can be transmitted over the network in a certain period of time. So it basically says the same thing that I told you earlier, that what is the maximum amount of data, maximum amount of bits that could be transmitted over that channel in a certain period of time. That certain period is most probably, and in majority it is 1 second. Okay, now how do we measure bandwidth? So basically bandwidth in bps is, example, gigabit ethernet can provide bandwidth of 1 GB per second. So 1 GB per second means bits per second, so this is gigabits per second. This means you can transfer 1 gigabits of data in a single second via gigabit ethernet. Okay, and bandwidth is basically the capability. Okay, bandwidth in hertz will be measured as a range of frequencies used to transmit signals, which is measured in hertz as a range of frequency. So if your bandwidth will be in between a range of frequency, suppose from x hertz to y hertz. All right, now coming on to throughput. What throughput is? So first of all, basically what bandwidth actually is the maximum capacity, and this is kind of hypothetical, because in actual, if it is written that 1 gbps is the bandwidth of this channel, then you are not able to actually transfer 1 gigabits of data. The data that can be transferred in reality is always going to be less than that bandwidth, and the real data in reality the amount of data, the maximum amount of data which you can transfer is throughput. So throughput is the actual amount of maximum data that you can transfer through that medium, not the highest limit of that channel. Bandwidth is actually the maximum limit of that beyond this limit you cannot transfer data. Beyond this limit, this is the limit, this is the maximum amount of data that you can transfer via this medium. However, there are a lot of problems in reality which decreases it, and as a final product, the actual amount is pretty much less than the original that was supposed to be, that is actual bandwidth. So that actual amount is known as throughput. So informal definition will be actual amount of data that passes through the medium. Okay, formal will be the throughput is a measure of how fast we can actually send the data through a network. Now look at this statement. If bandwidth of link is b, suppose it is b bits per second, and throughput is t, that is some t bits per second, okay, then t is always going to be less than b, that is the throughput is always going to be less than the bandwidth. It is a common, it's obviously common sense. The actual amount is always going to be less than the maximum limit. All right, now here's an example. We may have a link with a bandwidth of 1 MB per second, but the device connected to the end of the link may handle only 200 KB per second. So there comes a kind of limit to you, right? Now your data, your channel is obviously able to transmit up to 1 MB per second. Its bandwidth is given 1 MB per second. However, the device on the other hand is not capable of getting that much data. It only can handle 200 KB per second. This means that we can only send 200 KB per second through the link. So the actual throughput at that time will be 200 KB per second. It can't be helped. Alright. Unless of course the device is upgraded or changed. With that device, the throughput will remain 200 KB per second. Now coming on to the third important thing that determines the network performance, it is latency, that is delay. Latency or delay is how long it will take for a message to arrive completely at the destination from the time the first bit is sent out from the source. Please thoroughly see this definition. Try to understand it properly. It is written that latency is how long the first bit that the source will send out, how long that first bit is going to take to reach the destination. That is going to be the total latency, the latency or delay. Alright, now there are some components in latency. That will be transmission delay, propagation delay, queuing delay, and there was one another, it is processing delay. Okay, so latency, this latency will be a mixture, or rather saying a sum of transmission delay, propagation delay, queuing delay, and processing delay. They whole together will form latency. Okay, now checking out each of them. First of all, talking about transmission delay. So it is how much, okay, there will come a word that is much. Now it will be how much time the computer will take to put the entire data on the transmission medium. That will be known as transmission delay. So suppose if I am the source, I am transmitting some data to you. So that data, the time that I am taking to put the entire data on the transmission medium, suppose it is an Ethernet cable, so the time required to put that entire data on that transmission medium so that it is ready to now propagate to the destination, that time, that delay will be known as transmission delay. Here is a formula that is often used in competitive examinations to calculate transmission time, and as I earlier told you, it is often used in competitive examinations, so please keep it in mind. Transmission time will be equal to message size upon bandwidth. Okay, now propagation delay. So first I placed all the data that I had on the transmission medium. Now the delay or the time that is required for the very first bit that I placed on the transmission medium to reach the destination, that time will be known as propagation delay. Okay, so according to the definition, time required for first bit to go from device A, that is starting node, that is the sender, to device B, the ending node. Not the entire data, it is just the first bit. how long that bit is going to take. So that will be known as propagation delay. Propagation time will be determined as the distance, that is the length of the channel, upon propagation speed. Okay, just basically is equals to time equal to distance upon speed. Okay, propagation time will be equal to distance upon propagation speed. How fast the data propagation speed is, how fast the data is traveling. Now the third one is queuing delay. Queuing delay. Now let me give you an explanation first. Suppose you send a data, it is not directly going to get to the receiver, right? There are some intermediary nodes in between to maintain a connection, to provide you connectability to over long ranges. You have some intermediary nodes like routers in between. Suppose you there are a lot of data packets at the router that it has to process. Now it is processing other person's data first. Your data has to wait a little bit, right? While the router is processing other data packets, your data packet is needed to be on hold. Okay, the time your data packet will be on hold will be known as queuing delay, is known as queuing delay. According to the definition, the time needed for each intermediary node, intermediary device or end device, even if that is the end device, to hold the message before it can be processed. So suppose it is, as I earlier told you, it is processing some other data. For the time being, your data is needed to be on hold. That time will be known as queuing delay. Okay, now talking about the queuing time is not fixed. Of course the queuing time will not be fixed because nobody knows. It depends upon how many datas are in front of you that are being processed right now. So that will decide how long your data has to be on hold. Okay, so that's why it is written over here that the queuing time is not fixed. It changes with the load imposed on the network. I have written the concept that I told you earlier here. Let's give it a read. Suppose if there is a lot of traffic, then a router will be needed to process other data too, right? It has to process the other data too. And at the time it will be processing other data packets, your data will be needed to be on hold. This holding time is known as queuing time. Okay, when there is a heavy traffic on the network, the queuing time increases. Of course, if there is a heavy traffic, there are a lot of packets that has to be processed, that are needed to be processed. Thus your data packet might take a long time, a long queuing time. All right, at last we have processing delay. So basically the time that the end node will take to process the data. Suppose the entire data, I am the end node, you am the receiver. I received the entire data you wanted to send me. Now the entire data entire data reached me. The time that I am going to take, that is the end node, the receiver is going to take to process it, will be known as processing delay. Okay. Now there is one more concept, bandwidth delay product. The bandwidth delay product defines the number of bits that can fill the link. It's simply the capacity of the link. So suppose, let's take an analogy. So it is kind of suppose as a it is a pipe. Okay, you have a pipe of suppose it is 1 meter long pipe. Okay, and its cross section is suppose 20 centimeters. Let's take it 20 centimeters. So that pipe, how much water that pipe of 1 meter long and 20 centimeter wide of 20 centimeter cross section can have, how much it will be? It will be the, of course it is going to be the volume of that pipe. And how you're going to determine the volume? That how you're going to determine the entire capacity of that pipe. how much water at the maximum it can store in it. So it can be determined by deducting by getting out the volume. How you're going to get the volume? It is simply length into cross section, right? For that pipe, it's going to be length into cross section, certainly. So it is this the case is same with here. Now suppose this is the channel, okay. Now cross section will be bandwidth. Suppose this is the amount of data that can be transmitted in a single second. Suppose a single second covers just this much distance, that it can be considered as a cross section. Okay, so this is going to be the cross section bandwidth, and the delay can be considered as length. As long as the channel is going to be, the delay will increase proportionally. Okay, so volume, the capacity, the bandwidth into delay product. Okay, this is it. Volume is going to be bandwidth into delay. This is it. Now giving you an example, we just read here that volume is equal to bandwidth into delay, that is cross section into length. Suppose in a question you are given bandwidth is 1 bit per second, and delay is 5 seconds. Okay, now capacity of the link, what is going to be the capacity of the link? It's going to be bandwidth into delay, that is 1 into 5, that is 5 bits. So at the maximum, this link, if is going to be filled with the bits, it can store up to 5 bits only. This is the maximum capacity it can have. Okay, you can see here in the very first second, the first bit got transmitted as only 1 bit was able to be transmitted per second. So first bit took 1 second to be transmitted. Not to be transmitted, it's actually filling. Think of it as it is filling 1 second. 1 bit is filling 1 second. Assuming it like this, you can see the entire link is filled with 5 bits. It's completely filled with 5 bits now, and it took 5 seconds. As per the delay was 5 seconds. Okay, so yes guys, this was all for today. I hope you enjoy the session. Thank you for watching.